Ever find yourself, like, totally glued to the weather app?
Yeah.
Like, wondering how they get those forecasts so accurate? Or, let's be honest, sometimes so wrong.
It's wild, right?
Totally. So today's deep dive, we're going all in on weather data. All that behind-the-scenes stuff that makes those predictions happen. We've got some research here, some really interesting stuff that kind of pulls back the curtain on all the tools and tech.
Yeah, it's pretty
Right.
fascinating.
Right.
Yeah, from like basic rain gauges to, those satellites way up there orbiting the Earth. We're gonna like track how this data goes from, you know, a simple gust of wind to a prediction that pops up on your phone. It's a wild ride.
That's a really good point. It is a wild ride.
Yeah.
Okay, but before we get too deep into all that techie stuff, I just want to make sure we're all on the same page about some basic stuff. The research we're looking at, it makes this point about, the difference between weather and climate. And I think some people might say, oh, it's just like, semantics, whatever.
Yeah.
But is there really a difference?
Oh, there's a huge difference. It's super important. Think of it like this. Weather is the snapshot. It's like the current mood of the atmosphere. It's what you see outside your window right now. Sunny, rainy, windy, that kind of thing. But climate. Climate is the long-term personality of a region. It's built up over years and years of weather patterns, and it tells us about trends and averages.
So it's kind of like if weather is someone's mood swings, climate is their overall, I don't know, temperament.
Exactly. You got it. And just like understanding someone's personality helps us predict their behavior, well, understanding climate helps us anticipate long-term weather patterns. But to do that, we need data.
Which brings us back to all those cool weather instruments.
Yeah.
Our research mentions a whole bunch, and I think the easiest one to start with is that classic, the rain gauge.
Yes, the rain gauge. Simple but effective. It literally just collects rainfall. And that way we can measure how much has fallen over a certain time period. Of course, these days it's gone all digital, but the principle is the same.
Totally. And then there's the anemometer, right? I always picture those, those spinning cups on top of buildings.
Yes, you've got it. Anemometers, they're all about measuring wind speed. The faster the wind blows, the faster those cups spin, and all that data gets recorded.
Awesome. And our research also talks about temperature and humidity probes, and those seem pretty self-explanatory. Hot or cold, dry or humid, makes sense. But I'm curious about the solar panel that's mentioned. Is that just for, like powering these instruments?
Yeah, it is for powering them, but it's also a really cool example of how, sustainable technology is kind of intertwined with weather monitoring. Because by using solar power, you're reducing reliance on traditional energy sources. So you're making the whole process more environmentally friendly.
I love that. Okay, so we've got all these instruments out there collecting all this data. But how does all that information actually get turned into a forecast? Like what happens next?
Okay, so picture this. Each instrument, it's like a little data reporter, constantly taking notes on the atmosphere. They're recording things like temperature, wind speed, humidity, rainfall, all that stuff. And they often store that data in a digital format. So think of it like a super, super detailed spreadsheet.
Okay, so from sensor to spreadsheet, we've got a ton of raw data. Then what? Do scientists just like stare at these spreadsheets and try to spot patterns? I mean, how does that work?
That's where the magic of algorithms comes in. Algorithms are basically, sets of instructions that tell computers how to analyze all that data. And in weather forecasting, these algorithms are crazy sophisticated. They take all that raw data, they compare it to historical patterns, they factor in this super complex atmospheric physics stuff, and then boom, they spit out predictions. It's really impressive.
Wait, so it's not just one algorithm. It's like there's this whole team of digital weather detectives working on this, kind of.
That's a good way to put it. They actually use a technique called ensemble forecasting, which is pretty amazing. Imagine running like multiple weather models, each with slightly different assumptions, and then combining their results. It's like getting, I don't know, a second, third, and fourth opinion from the best weather minds out there, both human and digital.
Makes sense. So the source also talks about weather stations, which I guess are those like mini observatories that are packed with all these instruments.
You got it. Weather stations, they're like our ground level data hubs. They house all those instruments we talked about. Rain gauges, anemometers, thermometers, the whole gang. And they're placed, strategically all over the world so we can get this comprehensive view of what's happening in the atmosphere. It's a big network.
But we're not limited to just ground level data, right?
Yeah.
We've got those eyes in the sky, weather satellites.
Absolutely. Yeah, weather satellites, they orbit the Earth, so they give us a much wider perspective. They use all sorts of fancy sensors to capture images and data, things like cloud cover, temperature variations, even the amount of moisture in the atmosphere. And all this data gets beamed back down to Earth where it's fed into those, forecasting models we talked about. It's a whole system.
It's mind-blowing how much data is constantly being collected.
Hmm.
But this isn't just about knowing if we need a jacket tomorrow, right? This data has, like, a much broader
Oh,
impact.
for sure. Think about agriculture. Farmers rely so heavily on weather forecasts to decide when to plant, irrigate, and harvest their crops.
Yeah.
So accurate forecasts can literally mean the difference between a successful harvest and a failed crop. It's a big deal.
Yeah, and the source mentions disaster preparedness, too.
Yeah.
And, I mean, it makes total sense. Like, knowing a hurricane is coming can absolutely save lives.
Exactly. Weather data is totally crucial for predicting and preparing for those extreme events, like hurricanes, floods, heat waves. And those early warning systems, they're powered by real-time data. They give communities time, precious time, to evacuate or take shelter.
So we've gone from, simple rain gauges to super high-tech satellites.
Hmm.
And they're all working together to give us this, like, clearer picture of the weather. It's a pretty remarkable thing when you think about it.
It really is. And it kind of makes you wonder if we can use data and algorithms to predict something as complex and dynamic as the weather, what other systems could we potentially understand and forecast? Things like traffic patterns in a city, the spread of diseases, or even like fluctuations in the stock market.
Wow, that's such a good point. I mean, the possibilities are kind of endless.
They really are.
Well, thanks so much for taking us on this deep dive into the fascinating world of weather data. It's been awesome.
My pleasure.
And for everyone listening, keep those weather apps handy. And hey, maybe take a moment to appreciate all the incredible work that goes into those little predictions on your screen. It's pretty wild.